So here's an example of a chain rule problem. If you were given a composite function which has this inner function and then an outer function composed of -4 times the inner to the fourth power, we could write this as the inner function is 2x squared plus 6x plus 7. The outer function is -4 times whatever the inner was to the fourth power. And the chain rule says that you multiply the derivative of the inner times the derivative of the outer. And when we have the outer, we're going to plug the inner back in. Okay, that's what y prime would equal. So the derivative of the inner, in this case, would be, bring the 2 down, 4x plus the derivative of 6x is just 6, and the derivative of 7 is plus 0. So we wouldn't really even have to write that. So that's my inner derivative. I call it I prime. Now we'll do the outer derivative. If I was going to do the power rule on this, I would bring this power down, and I would have 4 times -4, or -16, I, and then I'd subtract 1 to my power and make that a 3. So I'm going to multiply these two things together. -16 I to the third power times 4x plus 6. Now the only thing I have to do is I do have to plug back in for this inner, like we said here. So wherever there's an I, I'm going to plug in what I said I was. So we'll have 4x plus 6 times, I'll go ahead and bring this -16 out front just so I don't think it's subtraction, but you could leave it inside as long as you use parentheses. And the inner function we said was 2x squared plus 6x plus 7, now to the third power. That would be our derivative of this rather complex function. Now let's take a look at another one. In this case, our inner function, it's composite again, our inner function is 4x squared plus 5x plus 2. We know we'll need the derivative of that, so I prime will just be 8x plus 5. That's the easy part. The harder part is that the outer function is equal to 3 over the cube root of whatever that inner function was. Well, that could be written as 3 over I to the 1/3, but we can't take a derivative until we have the power in the numerator, so I'll rewrite it one more time. 3 times I to the -1/3. Now I can use the power rule to find the derivative of the outer. I'd bring and that should be 1/3. I'll bring that 1/3 down, so we'll have 3 times -1/3 times I, and I'm going to subtract 1 in the form of 3/3 and get -4/3. Okay, and then I'll multiply these two, the I prime and the O prime. So we'll have 8x plus 5. This 3 and that 3 will cancel out, so I'm just going to have a negative in front from that negative right there. And I'll have whatever the inner function was to the -4/3. Well, this will be I is 4x squared plus 5x plus 2. This is an acceptable answer in Delta Math, and it's acceptable because it's correct. But you may sometimes want to deal with this by putting it back into the form it was given. So equivalently, we could also have 8x plus 5 all over 4x squared plus 5x plus 2. And now this is the positive 4/3 in the denominator. Well, I could instead rewrite that as keeping the 4 here, but reading this as the third root. That's equivalent to 4/3. This is another acceptable answer, and usually it's thought of as more simplified